Hello and welcome to Steps to Maths, and in this tutorial we're going to be looking at surds. We're going to be looking at simplifying and tidying irrational numbers. Okay, so there's two main things that you need to be able to do in order to do this. The first one is you need to be able to factorize surds. And the second one we're going to be looking at is rationalizing the denominator. So two techniques that we're going to be using in order to help us simplify and tidy up irrational numbers. So the first one is factorizing surds. So from powers, we already know that, for example, 6 to the power of 7, which is 2 times 3 to the power of 7, is 2 to the power of 7 by 3 to the power of 7. And we can do exactly the same thing with surds. We can say the square root of 8 is the square root of 2 times 4. Let's write that the other way around, 4 times 2. And that's equal to the square root of 4 times the square root of 2. And the reason we do this is we want to find a number, a factor of 8, that is a square number, because the square root of 4 is 2, and now we have 2 times root 2. We don't write the multiplication sign in because we don't need to in the same way in algebra. So we just write 2 root 2. Let's have a look at an example with the square root of 75. You want to split that. There's two possibilities for 75. You can split that into 5 times 15, or you could split that into 3 times 25. I'm going to pick root 25 by 3, and the reason I do that is because I can write the square root of 25 by the square root of 3, and 25 is a whole number, so the square root of 25 is 5, so I get 5 root 3. So I can simplify different surds by factorizing them, and that way I can make them into simpler surds, which helps me to combine them together. We'll look at rationalizing the denominator in a little while. Let's look at simplifying surds first of all. So let's look at an example. The square root of 98 plus the square root of 8 minus the square root of 18 plus the square root of 2. So it doesn't look like we can combine these. However, if you have a calculator, you can just type this in and you'll find that they do combine very nicely. But we need to understand how to do this question, because sometimes we come across questions in algebra that we can't just type into our calculator. The square root of 98, you will notice that is the square root of 49 by the square root of 2. The square root of 8 can be written as root 4 root 2. 18 can be written root 9 root 2. And root 2 is just root 2. Now obviously I picked these numbers carefully so that it would work out this way. In some questions you're not going to be able to combine other parts. For example, plus 75 would be adding on root 25 root 3, and then we'll have a root 3 rather than a root 2, so it won't combine too easily, but it helps us to tidy this up.
Powering off.
So the square root of 49 is 7, so we have 7 root 2. The square root of 4 is 2, so we have 2 root 2. The square root of 9 is 3, so I have 3 root 2, and root 2 is just root 2. Then we just count up how many we have. I have 7 plus 2, take away 3, plus another 1 is equal to, that's equal to 7 root 2's altogether. So there we go. We've tidied up a messy expression into a much tidier expression. And that's what we do when we factorize to simplify surds. Let's now look at rationalizing the denominator. Rationalizing the denominator helps us to tidy up fractions that have surds in them. So as you already know, if you have a fraction like 3 over 7, you can make that into an equivalent fraction by multiplying by 2 over 2 to make that equal to 6 over 14. You haven't changed the fraction, it's an identical fraction, it's just written a bit differently. And we can do that with surds as well. So there's two different things that we do with when we're rationalizing the denominator. If we come across a fraction, for example 3 over root 2, what we will do is we will multiply above and below by the square root of 2. That doesn't change the fraction, remember, just changes it into a different version of it. And the reason we do that is we end up with 3 root 2 on the top, but root 2 times root 2 on the bottom will give us 2 by definition. Similarly, 3 over root 8, we just multiply by root 8 over root 8. You know from before that you could play around with this a little bit, but let's just directly rationalize it. On the top we have 3 root 8, and then on the bottom we have 8. So it's a simpler fraction, it's easier to deal with. As I said, that's the first part of it. There's a second part to rationalizing the denominator. If we come across an irrational number that looks something like this, 8 over 1 minus root 2. So the denominator is not a simple surd, it's an irrational number rather than a simple surd. To rationalize this, we multiply by 1 plus root 2 over 1 plus root 2. And we'll see in a minute why that works. For example, let's have another example. Let's say I had 6 over 5 minus root 7. To rationalize that, I'd multiply above and below by 5 plus root 7 over 5 plus root 7. Remember, we're multiplying above and below by the same thing, so that doesn't change our fraction. It just makes the denominator easier to deal with. So let's look at an example of how we do this. Okay, so we have a fraction that we want to simplify by tidying it up by adding it together. And let's look at what we have. We have 5 over 2, that's fine, we don't have to change anything. 7 over root 2, we don't like that, so we're going to have to rationalize the denominator by multiplying above and below by the square root of 2. Let's do that. We multiply above and below by the square root of 2, and we'll tidy that up in a minute to see what happens. The next part, we have minus 6 over 1 minus root 2. Remember, to rationalize an irrational number like this, you multiply above and below by its conjugate. Its conjugate just means if that's 1 minus root 2, we multiply above and below by 1 plus root 2. If this was 1 plus root 2, we would multiply above and below by 1 minus root 2. So we just have exactly the same thing, we just put a minus in here and multiply above and below. Let's see why this works. Let's have a look at the bottom here, the denominator. I have 1 minus root 2 multiplied by 1 plus root 2. You might immediately recognize this, but otherwise let's have a look at doing that the long way. 1 times 1 plus root 2 minus root 2 times 1 plus root 2 gives us 1 plus root 2 minus root 2 minus root 2 root 2. These of course are gone. That leaves us with 1 minus 2. Root 2 by definition is 2. That's equal to minus 1. So we can see when we multiply above and below by the conjugate of the denominator, we get rid of the irrational part. That helps us. So we've rationalized the denominator. We no longer have an irrational part there. Let's look what we have. 5 over 2 plus 7 root 2 over 2. Remember, root 2 by root 2 is 2. Minus 6 times 1 plus root 2 over negative 1. Let's tidy this up a bit again. That's 5 over 2 plus 7 root 2 over 2 plus 6, because minus 6 divided by minus 1 gives us plus 6 times 1 plus root 2. I want that as a half, so I'm going to multiply above and below by 2. So that's equal to 5 plus 7 root 2 plus 12 times 1 plus root 2 over 2, which tidies up to 5 plus 12 is 17, plus 7 root 2 plus another 12 root 2 is 19 root 2 all over 2. Okay, so I had this is this part here. I just multiplied by 2 over root 2 because I wanted to make it a fraction, okay? So that's just what I did there to make it a fraction over 2 so that I could combine everything over 2, in case you missed what I did at that step. And that tidies up nicely into 17 plus 19 root 2 over 2, which might look a little complicated still, but as a single fraction, it helps us to work with it and makes equations much easier. Okay, so that's the different parts that we were looking at. We were looking at factorizing surds. That helps us to simplify and tidy them up, and rationalizing the denominator, which helps us to simplify and tidy up.